On the morning of July 25th, 1944, a column of Sherman tanks rolled toward a hedgerow near St. Lo that had already swallowed 3 American tank crews that week. The gunners inside were braced for the familiar horror, that terrible moment when a 30-ton tank reared up over a wall of earth and roots, exposing its unarmored belly to German anti-tank guns, waiting exactly where physics guaranteed the tank would appear. Then something different happened. The lead Sherman didn't climb. It didn't expose its underside. It simply punched straight through the hedgerow in a spray of dirt and torn branches, emerging on the other side at full speed, gun already tracking. Within seconds, 3 more tanks followed through freshly cut gaps of their own, fanning out where the Germans expected a single, predictable, vulnerable target. The Wehrmacht gunners had built their entire defense around a weakness that had just stopped existing. The device bolted to the front of that Sherman weighed about 400 pounds. It had no name in any army manual. The men who built it had welded it together from scrap metal scavenged off a beach. Within 3 weeks, it would help collapse the German line in Normandy and save an estimated 20,000 American casualties that never had to happen. To understand why that scrap metal contraption mattered, you have to understand what the American army walked into after June 6th. D-Day itself, the landings, is the story everyone knows, the one told in films and textbooks. But the truly desperate fighting started the moment soldiers moved inland, into a landscape that no planner in London had adequately reckoned with. This was the bocage, the ancient hedgerow country of Normandy, a patchwork of small fields enclosed by earthen banks 3 to 5 feet high, centuries old, packed with root systems so dense that a bulldozer blade would snap before it broke through. On top of each bank grew a wall of trees and thick brush, some of it 8 to 12 feet tall. From the air, reconnaissance photos showed neat green squares, orderly farmland. On the ground, it was a nightmare of 10,000 individual fortresses, each field its own defensible box, each hedgerow a natural rampart the Germans didn't even have to build. They just had to occupy it. American planners had rehearsed for beach landings, for urban combat, for open field armor maneuvers. Almost nobody had rehearsed for the bocage, because almost nobody outside Normandy had ever fought in it. The result was a killing ground, perfectly engineered by nature and ruthlessly exploited by German defenders. A Sherman tank attempting to cross a hedgerow had exactly one option: climb the bank nose first. The tank's tracks would grip the earth, its front end would rise into the air, and for 4 or 5 agonizing seconds, the vehicle's thin belly armor, designed to survive nothing heavier than a landmine, would be pointed directly at whatever was waiting in the next field. German gunners didn't need to guess where a tank would appear. The terrain told them. They positioned Panzerfausts and anti-tank guns at exactly the angle a rearing Sherman would offer its softest point, and they waited. First Army after-action reports from June 1944 described the hedgerow fighting in blunt terms, gains measured in yards, not miles. Some divisions took a week to advance 3 fields. Casualty rates in the infantry units clearing hedgerows by hand, squad by squad, field by field, ran higher per mile gained than almost anywhere else in the European campaign. Tank losses climbed just as fast. Crews that survived one hedgerow crossing dreaded the next one with the specific, learned fear of men who understood exactly how they were going to die if it went wrong. The army wasn't blind to the problem. Engineers tried explosives first, packing Bangalore torpedoes into the hedgerow base to blow a gap. It worked, technically, but slowly. and it announced the tank's exact position to every German position within earshot before the crossing even began. Bulldozer tanks, Shermans fitted with dozer blades, could occasionally punch through, but there were only a handful available, and the blades weren't designed for root systems this dense. Someone suggested welding heavy angle iron to a tank's front to ram straight through. On paper, it sounded promising. In practice, the vehicles that tried it either got stuck halfway through the bank, or worse, reared up anyway, exposing themselves in the same fatal arc as before, just a few feet further along. Command was aware something needed to change. What they didn't have was a solution, and the men who eventually found one weren't in a research lab. They were in a bivouac, staring at the same problem everyone else had, with materials nobody had thought to combine. The breakthrough came from a sergeant named Curtis Grubb Cullen III, a cavalry reconnaissance soldier with the 102nd Cavalry Reconnaissance Squadron, attached to the 1st Army. The story, as it's been told by the men who were there, has the particular texture of a genuine field improvisation, rather than a tidy engineering narrative. Soldiers in Cullen's unit were sitting around discussing the hedgerow problem when someone, accounts differ on exactly who first said it, mentioned the steel obstacles littering the invasion beaches, the ones the Germans had planted to rip open landing craft. Some called them hedgehogs, some called them Belgian gates, cross-braced iron beams driven into the sand specifically to tear metal apart. If those beams could shred a landing craft's hull, the thinking went, maybe they could shred a hedgerow's root system instead of trying to climb over it. Cullen is credited with turning the idea into hardware. Working with a small crew, using cutting torches and scavenged steel salvaged from the German beach defenses, they welded a row of sharpened steel tusks, prongs really, onto the front of a Sherman's hull, low to the ground, angled forward like the teeth of some improvised plow. The design let the tank's own momentum and weight do the work. Instead of climbing the bank, the tusks bit into the base of the hedgerow, sliced through roots and packed earth, and the tank drove straight through at ground level, hull down, never exposing its belly at all. They called it the Rhino. The name stuck instantly, and for good reason. It looked exactly like what it was, a mechanical animal built to gore its way through an obstacle rather than leap over it. The first tests were informal, almost casual by the standards of official Army development, but the results were immediate and undeniable. A Rhino-fitted Sherman didn't rear up. It didn't slow to a crawl. It hit a hedgerow at speed and came out the other side still moving, gun still level, crew still alive, in seconds, rather than the agonizing half-minute a conventional crossing required. Word moved up the chain fast, because results like that don't stay quiet in an army that's been bleeding for weeks over exactly this problem. General Omar Bradley, commanding 1st Army, reportedly saw a demonstration and immediately grasped what he was looking at. Not a minor mechanical curiosity, but the missing piece of an entire offensive he'd been trying to plan. He ordered mass production, except there was no factory, no supply chain, no procurement process fast enough to matter. So the Army did something almost unheard of in its logistics culture. It turned soldiers into a manufacturing line. Ordnance units up and down the front were directed to scavenge scrap steel, much of it stripped from the very German beach obstacles that had inspired the design in the first place, and weld rhino tusks onto every available Sherman. Estimates from unit records suggest that in the days before Operation Cobra, roughly 3 out of... The timing mattered as much as the invention itself. Operation Cobra, the breakout offensive designed to finally shatter the German line west of St. Lo, was set to launch in the last days of July 1944. Every previous attempt to punch through German defenses in the bocage had stalled in the hedgerows themselves, regardless of how much artillery or air power preceded it, because the terrain itself was the defense. Cobra's planners needed armor that could move fast and continuously once the initial breach opened, not armor that stopped to fight every single hedgerow individually. The Rhino tanks gave them exactly that. When Cobra launched on July 25th, Rhino equipped Sherman's lead columns straight through hedgerow after hedgerow at a pace German defenders had never had to account for. Positions that had been sighted perfectly to kill tanks rearing up over a bank found themselves facing tanks that never reared at all, that appeared through the hedge line already moving at speed, with their guns already tracking. The psychological effect matched the tactical one. German anti-tank crews who had spent 7 weeks training their aim on a predictable target suddenly had no predictable target to aim at. The results compounded quickly. Within days, First Army's advance, measured in agonized yards for the previous month and a half, was measured in miles. The German line, already stretched thin from weeks of attrition, couldn't reform fast enough once the bocage stopped functioning as a natural fortress network. Historians estimate that the hedgerow fighting through June and early July had been costing the American Army casualty rates comparable to some of the bloodiest fighting of the entire war on a per-mile basis. Cobra's rapid breakout, enabled in large part by armor that could finally move through the terrain instead of being murdered by it, shortened the Normandy campaign by weeks. Fewer weeks in the bocage meant fewer infantry assaults on entrenched hedgerow positions, fewer tanks caught rearing over embankments and German gun sites, fewer of the individual, field-by-field battles that had been consuming men and machines at a rate no planner had budgeted for. Precise casualty avoidance figures are always difficult to pin down with certainty, since you're measuring a war that didn't happen instead of one that did. But the estimate that Cobra's breakout and the Rhino device behind it saved on the order of 20,000 American casualties has been repeated by military historians studying the campaign, based on projected losses if the bocage stalemate had continued at its previous rate through August. What makes the story remarkable isn't just the tactical outcome. It's where the solution came from. This wasn't a weapons laboratory in the United States working through requisition forms and testing protocols. It wasn't a general staff study or an engineering corps directive. It was a sergeant and a handful of soldiers with cutting torches, staring at a problem that was killing their friends, looking at scrap metal from an enemy obstacle and seeing a tool instead of junk. Cullen himself was awarded the Legion of Merit for the invention, but by every account from the men who served alongside him, he treated the credit with some discomfort, insisting the idea had emerged from a group conversation rather than a single flash of individual genius. That modesty is, in its own way, consistent with everything else about the Rhino story. It wasn't built by a single inventor working in isolation. It was built by an army of soldiers who understood their equipment and their enemy well enough to combine the two into something neither the Army's planners nor the German defenders had anticipated. There's a particular irony worth sitting with. The steel that broke the German defensive line in the bocage had originally been placed on the Normandy beaches by German engineers, meant to tear apart the very invasion that would eventually use those same obstacles against them. Rommel's beach defenses, designed to kill the invasion in its first hour, ended up welded onto the tanks that broke his army's back 7 weeks later. It's the kind of detail that sounds too neat for history, the sort of thing a screenwriter might invent for symmetry. But the unit records and after-action reports confirm it happened essentially that way. War has a way of turning an enemy's own materials against him when the people fighting it are paying close enough attention to notice the opportunity. By late August 1944, the bocage was behind the Allied advance, a memory rather than an obstacle. The Rhino tanks that had spearheaded Cobra's breakout continued east with the armored columns, chasing the collapsing German front. Their improvised tusks, now just another piece of standard field equipment, unremarkable in the way that yesterday's brilliant improvisation always becomes today's ordinary tool once it works. Most of the men who welded those first Rhinos together in a French bivouac never received medals, never had their names recorded, and never expected to. They'd solved a problem because the problem was in front of them, and the materials to solve it happened to be lying on a beach a few miles away. The tank that broke through that hedgerow near St. Lo on July 25th didn't carry a secret weapon developed over years of research. It carried 400 pounds of scavenged German steel, cut and welded by soldiers who understood, better than any planner sitting in London, exactly what stood between them and the rest of France.